Greetings, everybody. This morning I got a question from my math lab. Somebody sent me a question, and it was by Ask My Instructor. So when you do that, if you see that option when you're solving a problem on my math lab and it says Ask My Instructor, it will send me a copy, and I'll be looking at this plus whatever answer you put in. And it helps me understand what you were working on. But this is the question I was sent, and this is the one that I want to do for now. Now I'll come back to this because part of what I need to show you is how do you solve the problem as it is, and then the second component is how do we put the answer in on my math lab. Okay, but let's address it like this. I'm given two functions, one called f of x, one called g of x, which you're looking at right here. And the first part of the question on my math lab is to find the function f plus g of x. And that is just what you would think it would be. You would think the function f plus g of x is the function f plus the function g. Okay, and that would be correct. And so here in green is me working that out. So in order to find this function f plus g of x right there, then I take 7 plus 9 over x plus 9 over x. And I simplify that however I can. How you simplify this might vary by question, but at least for this one, the way that I can simplify it is I can add these two fractions, 9 over x plus 9 over x. I can add any two fractions that have a common denominator. So the way that I add these two fractions, 9 over x plus 9 over x, is I add the numerators over the common denominator. So it's 9 plus 9 over x. Okay, so that's 18 over x. There's my answer. All right, so I want to say the function f plus g of x is 7 plus 18 over x. And then that would be my result. That's my statement about the answer. I don't think this part of it is so bad to put into my math lab. Let's see though. Okay. F plus g of x, 7 plus, and then I need a fraction, 18 over x. And then that should do it for part A of this. Okay. So I check it, and it's correct. Okay. Now, next for the domain. Okay, what's the domain of the function f plus g that I just found? Before I do that, let me do a little bit of review. In case you missed it when I've brought this up in other videos, or you just haven't seen it yet at all. To find the domain of a function, what we want to do is avoid any value of x that leads to division by 0 or square roots of negative numbers. The reason for that is just because those two things are not, we can't calculate them. Like if I take on my calculator, I say 7 divided by 0. What's that? Can I divide by 0? I don't get an answer. And that's the whole idea in a function, is that you put a number into the formula and you get an answer back out. So we want to avoid any value of the x, because the x is where we plug in our number, that leads to things that we cannot calculate. We want to avoid that. So when, for example, I look at this function, so this is a separate example, real quick. It says f of x is 4 over x minus 2. The domain is that x can be anything but 2. I want to avoid x being 2. Why is that? Well, what would happen if you put 2 right there for the x? What would you get? You would get 2 minus 2 down there, and you would be dividing 4 by 0, and you can't divide by 0. You can try if you want to, but it's not going to give you a result, okay? So the domain of this function is all numbers but 2. Now, when we work problems on my math lab, we will generally be giving domains in interval notation. So the way that I do that is I say, okay, to say all numbers except 2 is like saying all numbers from negative infinity to 2, skip the 2, pick back up, and go from 2 to infinity. So in interval notation, this right here says all numbers except 2. Interval notation and domain, I've brought up in other videos, but at least here I just wanted to make a statement about it, review it real quick, because I'm going to employ what I've given here over in this other example. Okay. All right. Now, so back to this one. What's the domain of that? See, here's function f plus g. What's the domain? Well, we would want to avoid any values of x that lead to dividing by 0 or square roots of negative numbers. This doesn't have a square root in it, so I don't have to factor that into it, but it does have division. Is it possible that you'd be dividing by 0 in this function? See, it says 7 plus 18 divided by x. We would want to avoid any value of x that led to dividing by 0. And so in this one, we want to avoid 0. So the domain would be x can't be 0. X can be any number except 0. Okay? All right. So here, just to contrast, it's x being 2 that leads to dividing by 0. If you let x be 2, you get 2 subtract 2, and then you're dividing by 0. But here, it's just that x can't be 0 itself. All right? Okay, now that's the domain. The problem from here, though, is that I have to put it into my MATLAB somehow. All right? So I'm given choice A, B, and C. Choice A says the domain of f plus g is, and it says use a comma to separate answers as needed. We would use choice A if the domain happened to be a short list of numbers. So for example, suppose that I figured out that the domain was 1, 2, and 3. Then I would put 1, 2, 3 separated by commas. But that's not the case for this one at all. Choice A is not what we want, and it's not applicable to this function. Choice B is what we want, because I can express the domain of this function as an interval. X not equals to 0 as an interval is negative infinity to 0, union 0 to infinity. Okay? All right, that's what I want. That is like saying all numbers except 0. That says x can be anything except 0. So that's what I want to put in here. Here's the way I do that. So I'll have to use the infinity key. So I want negative infinity. I put a comma, a 0. I close the parentheses. This symbol right here, this U, is the union symbol, and it's like it joins these two intervals together into one big one. All right. So I want that. Where's that? Right there. Let's see. I would like that copy and edit thing to go away, but I don't know why it won't. Okay, so the union symbol, though, is right here. Just looks like a U. And then I want, open the parentheses back up, 0 to infinity. So 0, comma, infinity. Okay, and that's the way that I would put in the domain as an interval notation. Okay, that says x can be anything but 0 because we can't plug in 0 to that formula. So I can check it and it's correct. Okay, now the same thing or something very much like what I just showed you would be true for f minus g and f divided by g. Okay, I'm going to skip ahead to the last part though. F minus g would be like what I just showed you. F times g would be like what I just showed you. I'm going to skip to the last one, f divided by g though. Okay, so here I am at the last part. Now, f divided by g initially is just what you think it would be. You take the function f, 7 plus 9 over x, and we divide by g, 9 over x. And then we simplify however we can. In this case, I'm dividing two fractions. So let me remind you or review how to divide fractions. If I have one fraction, a over b, divided by another one, c over d, I multiply by the reciprocal. Meaning I flip this one down here, c over d, and I multiply by it. So see what it says there? A over b times d over c. Then from there, I multiply straight across. It's a times b on top of b times c. That's how we divide fractions. So that's what I would do here, okay? I would take the reciprocal of 9 over x, which is x over 9, and I would multiply by that. So this is what I would be looking at, okay? Now, from there, I multiply these like so. I've got to take this and multiply it by that one. But we'll look at it this way. We'll look at the 7. Let's see, how do you multiply fractions? So you divide by multiplying by the reciprocal, but how do you multiply fractions? You multiply straight across, okay? A times d over b times c. So I'm gonna write the 7 if you want. If you think things line up and look better that way, you can say 7 over 1. So I gotta multiply 7 over 1 times x over 9. That's 7 times x over 1 times 9. That's 7x over 9. And then I multiply 9 over x over 9. That's 9 times x over x times 9. That's just 1, okay? Like if I took 9 over x times x over 9, I multiply fractions straight across. One way to look at it is it's 9x over 9x, 9 times x. And that's 1, so that's why I put 1. Okay, so we'll get 7x over 9 plus 1. Okay, so there's my function f over g. So we'll put that in. Shouldn't be hard to type that part in, but let's see. 7x over 9 plus 1. There it is. And that's correct. And then again for the domain. Now, I know that I said that to find the domain of a function, we want to avoid any value of x that leads to division by 0 or square roots of negative numbers. Okay? And you might look at this and say, that does not have, there's no way that there could be a division by 0 here. Because you see the division, what number is under it? 9. And 9 is going to be 9. 9 is not going to be 0. The only way the domain could be restricted, you might think, is if the x is under the bar in the denominator, because then potentially you could have division by 0, depending on what the x turns out to be. So this one doesn't have that. And it also doesn't have a square root. So you think either of these is impossible, but when we find the domain of a function in this case, whether you add the functions together, multiply them, subtract them, or divide them in this case, we do have to take note of anything that happened in the beginning. So although it's not possible to divide by 0 here in the simplified form, it could happen here in this one. Okay, so think about it like this. We did start right here, right? And because that's where we started, because that's the origin of this formula that I eventually found to be the answer, I have to consider that in that case, the x can't be 0, okay? You know, you began here. Could the x be 0? No. Why not? Well, because you'd be dividing by 0. So the domain turns out to be the same as it was in the other parts of this question. The x can't be 0, okay? And then if you want to put that as an interval, or if you have to put that as an interval, you would do that like this. All right. Negative infinity to 0, union 0 to infinity. So let's put that one in, and then we'll be done with this question. Now, I would put part B. Remember, part A is what we would put if the domain was like a short list of numbers, individual numbers. 1, 2, 3, 4, 5, something like that. We want to use choice B, which allows us to put the domain as an interval because that's what the domain is. Okay? All right, so I would type it in as I did before. There it is right there. Same as my answer for A or the other parts. Part A, part B, part C, and then this last part, part B. Okay? All right, so that's how we handled this question. That will at least allow you to get started on it. I've done 2 of the parts for you. But I make this video completely based on somebody asking me about that particular question on my math lab. If there's anything left you want to ask about for that question or any others, then let me know. And I'll make another video to follow up with it. We'll get it all covered depending on what you need to see from me.